In this session, we are discussing about the preparation of NTSE exam. In part of preparation, it is very important to analyze the previous year question paper, that is 2019 NTSE question paper. Here we can see the first question of the physics subject of the previous year question paper. Please watch carefully, and it is a matching of joule, watt hour and kilowatt hour. Here watch the first point, that is 1 joule is equal to how much? We already know that 1 joule is equal to 10 power 7 x. So A is matched with 0.3. And when coming to second point, that is 1 watt hour is equal to how much? We have 1 watt is equal to 1 joule by 1 second. And 1 watt hour is equal to joule by second into 1 hour. And it is equal to joule by second into 1 hour means 3600 seconds. So this second and second is cancelled, and it is equal to 3600 joules, and 3600 can be written as 3600 divided by 1000 into 1000 joules. 2 zeros and these 2 zeros are cancelled, and 36 by 10 means 3.6, 1000 means kilojoules. So we can write it as 1 watt hour is equal 3.6 kilojoules. When coming to another point, that is 1 kilowatt hour is equal to how much? Already we have 1 watt hour is equal 3.6 kilojoules. This is equal to 3.6 into kilo means 10 power 3. This kilo means again 10 power 3 joules is equal 3.6 into 10 power 6 joules. So 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. So 1 kilowatt hour is matched with 3.6 into 10 power 6 joules. And we have learned that 1 calorie is equal to 4.186 joules. So the answer is 2. Let's come to the second question, and in this question it contains assertion and reason, and we have to check whether it is true or false. Assertion is the velocity of a particle may vary even when its speed is constant. Reason is the particle is moving in circular path. Let us consider one particle which is moving in circular motion as shown in figure. As long as the particle is moving in uniform circular motion, its speed is constant but its velocity is changed. Why? Because speed is a scalar quantity and velocity is a vector quantity. Vector quantity means it has both magnitude and direction. That means velocity has both magnitude and direction. If a particle is moving in a circular path, its speed is constant but velocity is not constant. Why? Because the direction of the particle is changed from one point to another point. So the first option is correct, that is both A and R are true, and R is the correct explanation to A. Let's come to the third question, that is a convex lens of focal length 20 cm is cut into two halves, each of which is placed 0.5 mm and a point object is placed at a distance of 30 cm from the lens as shown below. In this problem it is given that a convex lens is taken and it is cut into two halves horizontally. So before solving this problem we have to understand some concepts regarding this problem. First of all, we all know that focal length of a convex lens is always positive. Focal length of a convex lens is always positive, and if convex lens is cut into two halves horizontally, then its focal length is equal to same as the original focal length. And in second case, if the convex lens is cut into two halves vertically, then its focal length is doubled. Suppose if the focal length of the convex lens is 10 centimeters, if the focal length of the convex lens is 10 centimeters and it is cut into two halves horizontally, then the effective focal length is equal to 10 centimeters. If the focal length of the convex lens is 10 centimeter and if this convex lens is cut into two halves vertically, then the effective focal length f dash is equal to, it is doubled, that is the effective focal length becomes 20 centimeters. In our problem, it is given that a convex lens is given and it is cut into two halves horizontally as shown in figure, and the distance between two halves is 0.5 mm. That means these two halves were placed such that the distance between these two halves is 0.5 mm. So the focal length of a convex lens is given and it is 20 centimeters. So we already know that the focal length of the two halves is also 20 centimeters. Why? Because if the convex lens is cut into two halves horizontally, then each half having the focal length of 20 centimeters, and we already know that the focal length of a convex lens is always positive, so focal length of a convex lens is equal plus 20 centimeters. And also it is given that object is placed at a distance of 30 centimeters. Object is placed at a distance of 30 centimeters. So suppose object is placed here and the distance between this object and the lens, that means midpoint of the lens, is 30 centimeters. So on adding the sign convention, the light rays coming from the object like this, and we have to measure the distance between this object and the lens from this point, that means pole of the lens. So this distance should be measured from pole to object and the light coming from the object to the lens like this. So these two are opposite to each other, so we have to take the negative sign for the object distance. So u is equal to minus 30 centimeters. So understand, so object is placed here and the light coming from the object like this and falls on the convex lens, and upon the sign convention we have to take the distance between object and the lens from this pole. So we have to consider the length from pole to object, and the light rays are coming from object to pole, so these two are opposite to each other. That's why we have to consider the object distance is equal to minus 30 centimeters. So focal length is given and object distance is also given. So now we have to find out the image distance. So we have the formula, that lens formula, that is 1 by f is equal to 1 by v minus 1 by u. So implies 1 by v is equal to 1 by f plus 1 by u. So 1 by v is equal to 1 by f means 1 by 20 minus 1 by u means 1 by 30. So LCM is 60, so this is 3 minus 2 is equal to 1 by v, implies 1 by 60 is equal to 1 by v, implies v is equal to 60 centimeters. That means image distance is equal to 60 centimeters. Image distance is equal to 60 centimeters. This is the required answer. So the third option is correct. Coming to the fourth problem, that is, which of the following graph represents non-uniform acceleration? Here are four graphs are given. We have to select the graph which represents non-uniform acceleration, and in the figure the first option gives the graph between time and speed and it is for uniform acceleration. Second graph shows the constant speed. Third one represents the non-uniform acceleration. Fourth one represents the uniform retardation. Retardation means decrease in acceleration. So the required answer is 3. This is fifth question, and here assertion and reason are given, and we have to say which one is true and which one is false, and we have to say whether it is correct explanation or not. Work done by gravitational force in a moving body path is independent. Reason is gravitational force is non-conservative force. Before understanding this problem, we have to recapitulate the knowledge of conservative force and non-conservative forces. So I will explain the definition of conservative force and with an example. So here is this is earth, and a man is standing on the earth and he is moving on the earth, and gravitational force acting upon this man like this in this direction. This is gravitational force. This is gravitational force. This is gravitational force, and a man is moving on this horizontal direction. So the path followed by the man is like this, and this path is independent of the gravitational force. Even though gravitational force is acting like this, the man did not follow the path of this force. So that force is called conservative force. That means the force is acting upon the body and the path followed by the body is independent of this force, and that force is called conservative force. So gravitational force is an example for conservative force. So in our question, gravitational force is non-conservative force. So option 3 is correct, that is A is true but R is false. And when coming to sixth question, it is find the current flowing through the above circuit, and it is basing on Ohm's law. So the circuit can be drawn as like this. In this circuit, 4 ohms, 2 ohms, 4 ohms are connected in parallel. So let's find out the effective resistance for this parallel combination, that is 1 by 4 plus 1 by 2 plus 1 by 4 is equal 4 is LCM, 1 plus 2 plus 1, this is equal 4 by 4 is equal 1 ohm. So the effective resistance for this parallel combination is 1 ohm. Then 3 ohms and this 1 ohm and this 4 ohm are connected in series. Let's find the effective resistance. 3 plus 1 plus 4 is equal. So the effective resistance is 8 ohms, and we have the formula using Ohm's law. V is equal to IR, or I is equal to V by R is equal to, V means 3 volts and R means effective resistance 8 is equal to 0.375 amperes. So the option 2, that is 0.375 amperes is correct. When coming to next question, it is a matching, and in this matching we have to match the gravitation values of each planet. So Earth, Jupiter, Saturn and Mars, and these are having particular values, and the option 4 is correct for this matching. And when coming to 8th question, bulb P marked as 100 watts to 20 volts and bulb Q marked as 60 watts and 110 volts, the resistance ratio of P and Q is. In this problem, it is given that there are two bulbs P and Q. This is for bulb P and this is for bulb Q, and power and voltage are given. So power for bulb P and voltage for bulb P and Q are given, and power and voltage for bulb P is 100 watts and 220 volts. and for Q bulb it is 60 watts and 110 volts. So we have to find out the resistance in both the cases, and we have to obtain the resistance ratio for each bulbs. So for this purpose we have to obtain the relation between power, voltage and resistance for both the bulbs P and Q. So we have the one relation, that is power P is equal to work by time, and again we have work is equal to VQ, work is equal to VQ. V means potential energy and Q means charge and T means time. So again we write it as Q by T is equal to current I. So in this way we can write it as V into Q by T means I. So power P is equal V into I. That means and again we can write it as I is equal to V by R. That means where I is the current and V is the potential difference and R is the resistance. In this way we can write it as V into V by R, and this is equal to V square by R. In this way we can obtain the relation between power and potential difference and resistance. So this is the required relation, that means power, voltage, resistance, power, voltage, resistance. So we have to find the resistance in this case, and we also find the resistance in this case, and the ratio between these two gives the answer. Let's do the solution. So from this equation we get the resistance relation, that is R is equal V square by P. So in first case we have to find the resistance, and in second case we have to find the resistance. That means for P bulb we have to find the resistance, and for Q bulb we have to find the resistance, and the ratio between these two gives the answer. So in first case, that is R means V square by P. So V square means 220 into 220 divided by P means power 100 watts. So ratio means it is a fraction. So we have to write the resistance value of Q, that means V square by P. So in this case V square means 110 into 110 divided by P means power. Here it is 60. So it is 60. So this is the answer. We have to simplify it. That means 220 into 220 divided by 100 into, this fraction is reverse, 60 by 110 into 110. So this 0 and this 0 cancel, and 0 are cancelled. This 0 is cancelled. It's 11, 22 2 times. So next 11, this 2 times, and this 2 5 times. 2 into 6, 12 by 5. That means 12 is to 5. So 12 is to 5 is the required ratio of resistances for both the bulbs P and Q.